Why India's AI dreams will fail without this one fix. The rhetoric-reality gap. On August 23, 2026, Delhi CM Atishi articulated a vision that has echoed across Indian policy circles for 2 years. Position India not as a consumer of AI tools, but as a creator of foundational systems. The framing is politically compelling. India trains 1.5 million engineering graduates annually, a scale that dwarfs most developed nations. Yet when you map where this talent flows, a troubling pattern emerges. The pipeline doesn't route toward frontier AI research or model development. Instead, it fragments into 3 low-leverage channels. 1. Outsourced software services, TCS, Infosys, HCL. 2. Mid-market SaaS features, B2B2C, platforms copying Western playbooks. And 3. Emigration to US tech hubs. The Delhi CM's statement assumes the constraint is ambition or policy clarity. It isn't. The constraint is structural. The hidden filter, curriculum misalignment. India's engineering education system was architected in the 1990s to 2000s to produce reliable enterprise software engineers, the backbone of the $230+ billion Indian IT services export model. This design choice had enormous benefits. It created a predictable talent pipeline for Bangalore and Delhi NCR service firms, anchored India's global tech presence, and lifted millions into middle-class employment. But it also created a subtle, durable misalignment with frontier AI work. Consider the curriculum reality. Most of India's 9,400+ engineering colleges, as of 2025 data, teach 4-year programs structured around Java, relational databases, software design patterns, and enterprise architecture. Capstone projects often involve building CRUD applications or dashboards, valuable skills for shipping production systems, but not for research. Contrast this with MIT's approach. Even undergraduate CS programs now integrate linear algebra, probability theory, neural network implementation, and research methodology into core coursework. IIT Delhi, IIT Bombay, and IIT Madras have begun adding AI electives, but these remain optional and peripheral. Most students graduate without ever implementing backpropagation from scratch, understanding transformer internals, or conducting empirical ablation studies. This isn't a knowledge gap, it's a practice gap. A student who spent 4 years building CRUD apps in a structured bootcamp setting has developed strong habits, ship fast, iterate on user feedback, minimize technical debt. These habits are misaligned with the 18 to 24-month patient capital cycles that frontier model development requires. When that graduate receives a venture term sheet offering seed funding for an AI-powered analytics platform, i.e. a wrapper around OpenAI Claude APIs, the incentive structure colludes with habit. Why spend 2 years on a novel pre-training approach when you can ship a product in 8 weeks? The venture capital compression effect. India's venture ecosystem has become remarkably efficient at funding SaaS, EdTech, and FinTech, categories that promise revenue within 12 to 18 months. According to NASSCOM's 2026 report, around 68% of AI-focused funding in India still flows to B2B SaaS tools and vertical solutions, healthcare AI, legal doc processing, customer support automation. Only 12% funds foundational research or model development. This is rational for VCs with 5 to 7-year fund horizons and GP clocks. A $15 million Series A for AI for X industry is a clearer bet than $3 million for a TAM attempting to build a domain-specific foundation model. What's missing is the institutional gap filler. In the US, this role was historically filled by DARPA grants, NSF funding, and lab positions. Google Brain, DeepMind, OpenAI research. These provided the 5 to 10-year patient capital runway that enabled researchers like Ilya Sutskever, Dario Amodei, and others to take risks on ideas that might fail. India has no equivalent. The DOE's CPU scheme, roughly $100 million over 5 years, and CDAC's efforts are non-trivial, but they're dwarfed by the scale of the problem. Retaining just 500 top-tier AI researchers with multi-year funding would require $50 to $75 million annually, less than a single Series C in B.